Hello, good morning. I am Dr. Bedabati Chowdhury. So today my topic it is the regarding the hot air oven, and the PPT I have made it only for the students of the BSc in botany. Even the microbiology students also, they can also go through that. So what is the hot air oven? It is an instrument which is used in our routine laboratory practice, and it is an oven which provides a temperature which is higher than the atmospheric temperature, and here the temperature also ranges from 50 to 250 degree. And the hot air oven, it is mainly used for the dry sterilization of the substances. And so it is used for the rapid evaporation of materials, for rapid drying, and for sterilization of articles that can be sterilized only by the dry heat. So the contents in my presentation contains the instrumentation, the working principle, the advantages and the disadvantages, and what are the other general uses. So the dry heat sterilization technique, it requires a longer exposure time, about 1.5 hours to 3 hours, and the higher temperatures than moist heat sterilization. And the hot air ovens, these are actually, it looks like an oven. And if you see it, looks, it is an electrical device, and it is used the dry heat to sterilize. And this technique, it was developed by Louis Pasteur. So here the temperature ranges around 50 to 300 degree, and the instrument itself contains a thermostat which can control the temperature, and the instrument contains a double walled insulation which keeps the heat inside it and conserves the energy. And there is also air spaces there between the uh, between the outer layer and the inner layer. So here inside this, there is a fan is also there where the air is circulating, so which helps in a uniform distribution of the heat. And these are fitted with some adjustable wear mesh uh, plated trays, or the aluminum trays are there. There we can keep the our substances that we want to sterilize. There are some indicators, temperature indicators are there. So the power supply also needs to vary from country to country depending on the voltage and the frequency. So some temperature sensitive tapes or the biological indicators are also used. Suppose bacterial spores which are used as a controls, these are used to test the efficacy of the device during the use. The principle behind it, it is the sterilization by the dry heat is accomplished by the conduction, where the heat is absorbed by the outside surface of the item, and the heat, it goes layer by layer, and thereby the entire item, it is eventually the item, it gets the heat, and ultimately sterilization takes place. So the dry heat here does the most the damage it does by the oxidizing the molecules, and the essential cell constituents here destroyed, and the organism, it dies. So here is the picture. This is picture, it shows the inner part of the hot air oven. And here it works. Suppose if you see the working principle there, if you sterilize for 30 minutes, the temperature, you have to give 170 degree or 340 degree Fahrenheit. And if you give for 1 hour or 60 minutes, then the temperature should be maintained at 160 degree or 320 degree Fahrenheit. And if you carry out for 150 minutes or longer, then 150 degree centigrade or the 300 degree Fahrenheit temperature is sufficient for the sterilization. And the contents after the sterilization need to be cooled, otherwise these may crack. After that we can bring them out. The used, suppose glasswares, we can sterilize forceps, we can sterilize, then swabs, then water impermeable wells, then waxes, then powders. These things we can sterilize. And before placing in the hot air oven, the glassware should be dried completely. And sometimes the plug test tubes with the cotton wool also, these are placed, and the glassware should be wrapped in the craft paper before placing it in the hot air oven. And we should not overload it. and so otherwise the free air circulation will be hampered. And how to check it, how to check that the hot air oven is working properly or not? Then in that case we can use some chemical controls. For example, brownish tips. So brownish tips is that if the color changes from the red to green, it will signal that it is, yes, it is good. And even sometimes some biological controls are also used to test the working capacity. So suppose paper strips which contain spores of the clostridium tetani sometimes used. So the thing is that the strips are kept in the hot air oven for the sterilization, and later that we have to culture the strips in the thioglycolate broth at 37 degrees for 5 days. If there is no growth, then we can say that our instrument it is good. But if any growth of the microbes is found, then there must be some failure in the instrumentation. Then we need to go check it if there is some problem is happening in our instrument. And what are the advantages is that the dry heat is cabinet, it is easy to install and has a relatively low operating costs, and it is penetrates the material, it is non-toxic and does not harm the environment, it is non-corrosive for the metal and sharp instruments. And the disadvantages are that it is a time consuming method because it is a slow rate of heat penetration and the microbial killing, and sometimes the high temperatures are not suitable for most of the materials. So this is my short presentation for the BSc students.